Mathcad Prime 7.0 has a new input control called a combo box that allows you to change the value of variables from a drop-down list. Let's take a look at how to use it. So the first step that you will do is to create a matrix for all the different values that you want to select from a drop-down list. And I'm going to do this for material properties. Let's go to the Matrices Tables tab. And then I will go to the Insert Matrix drop-down list. We're going to create a vector. In other words, it's just going to have one column and multiple different values. And so in this input box, I want to have people be able to assign the value of density and Poisson's ratio and Young's modulus. So let me create the row character, the letter R, and then Control G. And then I'll use the down arrow on my keyboard to go to the next element of the vector. And this will be for Poisson's ratio. I don't think there's a standard symbol for Poisson's ratio, so I'll just write Poisson. And then for Young's modulus, I will use E. Now I will use the right arrow on my keyboard to position my cursor on the right side of the vector. Then I'll use the keyboard shortcut of the colon key for the assignment operator, or the definition operator. This is going to now be set equal to the combo box. And I'll click on that, and here you can see what we end up getting. And right now we have a bunch of empty placeholders, and I want the person to be able to select 3 different materials from here. The first one will be steel, so I will type in that value. Also, in the upper left-hand corner, you can put in the name of the combo box. So this will be material. And I also want to have 2 more materials. Let me position my mouse to the bottom line, and then I can go back to the Matrices Tables tab, and we're going to insert below 2 more times. And so the next material after steel will be aluminum. And then after that, I will put in titanium. So the first column is going to be for the density. And here we can put in the units. So my units are going to be in grams per cubic centimeter. And by the way, I'm going to warn you in advance, this is going to cause a problem, and I'll show you how to fix it later on. And so for steel, we'll put in a value of 7.9. For our aluminum, it'll be 2.7, and for titanium, 4.5. So I've got my density in here. Now we need to do Poisson's ratio and our Young's modulus. Let's insert 2 more columns, and the units for Poisson's ratio, it's actually unitless, so we don't need to fill in anything over there. So for steel, this is going to be a value of 0.25. Then for our aluminum, I'll use 0.36. And for titanium, 0.34. The third column is going to correspond to Young's modulus. And for Young's modulus, I've got my values in gigapascal, so I'll type in GPa. And the values for this, 200 for steel. And then we have 68 for aluminum. And the reason everyone likes titanium, hey, we have a good value for Young's modulus, but it is relatively light. All right, so there I have the table filled out. Now I'm going to click outside of the cell, and you'll notice that we get this red sort of box around it, indicating that there's a problem. This isn't going to work, and that's because combo boxes do not support units that are like a math combination, like divided by, squared, cubed, anything like that. So if I right click and choose, let me click on here. Here we have the different materials. Now I'll right click and choose edit. The problem is with this unit, grams per cubic centimeter. So I'm going to create my own custom unit. Let's now click above the combo box, and I'm going to call it GCC for grams per cubic centimeter. Now I'll go back to the Math tab, and I've got to change the label. I'll change the label from automatic, because if I leave it automatic, it's going to think this is a variable. I'm going to change this to unit. You'll notice, if you have good eyes, the color changed to the standard blue color for units. Then let's use the definition operator, and this is going to be equal to grams divided by centimeters. Then I'll use Shift 6 to get the superscript, and let's put in a 3 over there. Let's click outside, and now I will right click on the combo box and edit. Let's get rid of this unit out of here. Let's change to the custom unit that I just created, GCC. Hey, we no longer have that red box around the drop-down list, indicating that everything is okay. And at any point now, I can change what the material is being used. Let's now calculate some values. Let's create row R, Control G. Let's do equals. And here you can see it's being reported in our unit system of metric. Let's also evaluate Young's modulus. Let's do E equals, and you can see the value in pascals. If I change the drop-down list from steel to aluminum, you'll notice that the density and the Young's modulus update. Let's do that one more time for titanium, and we can even use these now in different equations that we want to evaluate. So let's take a look at doing a calculation for deflection, the easiest engineering calculation there is. Let's define a load P, and I'll use 10,000. Oops, hold on, let me try that again. I accidentally created a range variable. Let's do P colon is equal to 10,000. Must have accidentally hit the comma. And then let's multiply this by pounds force. And yes, I am mixing SI and English units. And the next one I need is a length. The length of this, let's make this equal to 10 feet. And for the cross-sectional area, I have a 2x4, so this is going to be 8 square inches. And now let's compute a deflection. And I'll use the letter D, then Control G to convert it to the Greek letter. This is going to be equal to P times L. I'll use the space bar to highlight everything, divided by A times E, and then we can evaluate, and you can see what the deflection is. Let's change this to millimeters, and let's also go to the Math Formatting tab. Let's change this. I like decimal, and I like more decimal places since the value is going to be so small. So here you can see the calculated deflection with titanium, and then I can say, hey, what if we make this out of steel? And we can see that the deflection went from about 0.22 to 0.13. If we go to aluminum, it goes to 0.38. Hey, it is much worse. And so we can change the selection from the combo box, and it updates the different evaluations and calculations in our worksheet. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.